Hi, ladies and gentlemen. So far, we have seen the sum of product expressions, and we saw the simplification of sum of product expressions by Karnoff map and the way to implement them in Qux and Side and Verilog. Now, there's an alternate representation that's a complementary representation called the product of sum expression. In this video, I tell you about the product of sum expression, and let me start with that presentation. What you in this video, first the learning outcomes, then the product of sum expression, and the four variable POS expression, and summary of what you learned. What you will learn in this video is that you will learn product of sum expressions, then you will learn its relation with the SOP expression, then you will learn to reduce POS with the K-maps. Now, the sum of product expression is of the form y equal to sigma mi. If complemented, it becomes a complement of sigma mi, which becomes a product of mi complement by De Morgan's law. So, for example, if I have a term like a sum of product expression like y equal to m1 or m3 or m5, let us take the complement of that. It becomes m1 or m3 or m5 all complement, which becomes m1 complement and m3 complement and m5 complement by De Morgan's law. So what is M1, M3, M5? Suppose if my inputs are A, B, C, M1 is 0, 0, 1, which is A bar, B bar, C, all complement, and this is 3, 0, 1, 1, that is A bar, B, C, all complement, and M5 is 1, 0, 1, that is A, B bar, C, all complement. Now by De Morgan's law, the first term is A or B or C complement, and second term is A or B bar or C bar, and A bar or B or C bar. Now this is of the form of a product of sum expression. Now we have three sums or ORed together. Three sums are there. They are ANDed together. So this is of the form of a product of sum expression. So this comes as an OR array followed by a single AND gate. Okay, an AND array, or arrays followed by AND arrays. First they are ORed, then they are ANDed. In the sum of product expression, we had first we had the AND array, and in the end we had the OR array. Now it is just a complement of that. Now let us, this is called a product of sum expression. Now this corresponding truth table, if you say this M1, M3, M5, they are ones, this is the truth table, and if I put this into a K-map, the speciality is that everything is complemented. So instead of grouping ones, I group the zeros. Now here, this is a three variable Karnoff map. C is the variable here, that is the LSB part, and this is the MSB part. So this is C 0 and 1. This is 0, 0, 0, 1, 1, 1, 1, 0 as in the usual gray code manner. And here if you put this, these values are 0, 1, 0, 1, 0, 1, 0, 0, 0, 1, 0, 1, 0, 1, 0, 0. Now instead of grouping the ones, I have to group the zeros. If I group these zeros, I can see that this is a quad. This what is happening in the blue oval is a quad, and what is happening in the red oval, that is a pair. Now, corresponding to this blue oval, the time, it is called a max time. The max time corresponding to the, in contrast with the min time in the sum of product expression. This is max time. In POS, it is a max time. That corresponding to this blue oval, it is C. It is not C complement, it is C, because everything is complemented here. We are considering zeros here, so this is C. The max time corresponding to this red oval, here it is happening in this blue oval is happening in one row and four columns, so everything is varying in the four columns, so it depends only on the C variable, it is C. Now as for this red curve, red oval, it is happening in two rows and one column. So in the column nothing is varying, but in the row the C is varying, so it is not a function of C, it is a function of A and B alone. But here it is 1, 1, so it is A complement or B complement. A complement or B complement. So the product of sum expression is y is equal to C and A complement or B complement. So this is how the product of sum expressions do happen. You can verify this. You can design the circuit in Qux and verify that. Now let us consider a four variable Karnoff map. Suppose I have a expression where this pi value or the complemented values, they are occurring zeros occurring at 0 to 4 3 4 etc. So that this came up looks like this. So if you come here, this is m0, m1, m2, m3, like zeros are coming here, m0, m1, m2, m3, then m4, m5 is a 1, m6, m7, then m8, okay, m9, m10, m11, then m12 is a 0, m13, 14, 15, okay. So ones occur at these points and zeros occur at this point. Here these zeros just form a quad, and these zeros form another quad. So corresponding to the blue oval, I have the time C or D, because this happens in 4 columns and 1 row. So here the variables are 0, 0. It's a complemented form. It is C or D. And max time corresponding to the red oval, that is here what does not vary is C, and here what does not vary is C bar. Here what does not vary is C bar, and what does not vary here is A. So it is A or C bar. Now the simplified POS expression will be C or D and A or C bar. This is how you realize, this is how you enter the values in the came up and group the zeros together and get the product of sum expression. Now what you learned, or you understood the product of sum expressions, then you learned the relation with the SOAP expression, and you learn to simplify the POS expressions with the came ups.